Hello friends, today we will discuss about nature of bonding in organic compounds. To understand this, let us take an example of carbon. Carbon, atomic number 6, electronic configuration 1s2, 2s2, 2px1, 2py1. That means it has 4 electrons in its valence shell. In order to acquire a stable noble gas configuration in its compounds, carbon should either lose or gain 4 electrons. When it will do so, it will be converted into its ionic form, that is, it will be either in the form of C+4 or C-4. Now, I can say if they have tendency to form these ions within their compounds, then that means they can form ionic bonds within their compounds. However, this ionic bond existence requires high amount of energy for formation of such ions. This implies that carbon cannot form ionic bonds in its compounds due to requirement of very large amount of energy. In other words, I can say covalent bond is the bond of main importance in the formation of organic compounds. According to orbital concept, when can a covalent bond be formed? It can be formed when a half-filled valence orbital of one atom overlaps with a half-filled valence orbital of another atom. Now in the same case, if I consider carbon, carbon has two half-filled orbitals, 2px1 and 2py1. That means it is expected to form only 2 covalent bonds. But in actual practice, carbon is known to have a covalency of 4 in its compounds. That we can understand with the example of methane, CH4. As we can see very clearly, it is forming 4 bonds with 4 hydrogen atoms. So, carbon is having a covalency of 4 in this case. To explain the tetravalency of carbon, we can understand it by the formation of bond concept. If I consider the ground state of carbon, the electronic configuration is in this form: 1s2, 2s2, 2px1, 2py1. Now, if I want carbon to show its tetracovalency, then I need to promote this 2s electron to the higher energy level, that is 2p. So as we can say, due to this promotion in excited state, the 2s electron gets promoted to 2p orbital, and now I have 4 unpaired electrons. That is, it has achieved its tetracovalency. That means we are able to see here that in its new state, that is excited state, the carbon atom has 4 half-filled valence orbitals which would be available for the formation of covalent bonds. It may be noted that during this formation of 4 bonds by carbon, it results in lowering of energy, and as a result it forms more stable molecules compared to that when carbon was expected to form only 2 bonds. See here, when carbon in its ground state interacts with 2 hydrogen atoms having 1 electron each, then it is able to form CH2 molecule. As we can see, in CH2 molecule, there is formation of 2 carbon-hydrogen bonds. Each carbon-hydrogen bonds has a tendency during its formation to release 418 kilojoules per mole. So, because of that, we can say, due to this formation of 2 CH bonds, it now releases 2 into 418 kilojoules per mole, that is 836 kilojoule per mole of energy is released. On the other hand, if I consider during the formation of methane molecule, carbon originally is in its ground state. Since we need a tetracovalency for carbon in this case, so it initially absorbs 400 kilojoule per mole of energy. gets promoted, comes into its excited state in this form, then it interacts with 4 hydrogen atoms with 1 electron each and results in the formation of a methane molecule. In methane molecule, there are 4 carbon-hydrogen bonds. Each carbon-hydrogen bond, during each formation of carbon-hydrogen bond, 418 kilojoule per mole energy is released. So, in general, we can say how much energy is released in this case? 4 into 418 kilojoules per mole. That comes to a total of 1672 kilojoules per mole. So, if we consider the net release of energy during the formation of methane molecule, that comes to 1272 kilojoules per mole, which suggests that a larger net release in energy, that means the molecule is comparatively more stable. That means CH4 is a stable molecule compared to that of CH2 molecule. It makes us understand about the importance of covalent bonding in organic compounds. That's for today. Study hard. Take care.